Hello dear friends, welcome to Humble Math Academy. In this video guys, we shall be looking at the correction of the Northwest mock, the mathematics with mechanics and statistics guys, paper 2 of 2024. We shall be looking at the question, the paper 2 from question 1 to question 10. So guys, stay connected because we shall be highlighting all the various concepts that are necessary for you to score all the marks as far as this particular paper is concerned. Friends, before you get started, I want all of you to hit that subscribe button looking at you, because that is the only way you join our academy, where we help students for free of charge to pass their exams with very good grades. Alright, so guys, please like the video by clicking on the like button beneath this video. That goes a long way guys to motivate my team and I to keep on creating more great content for you. Thank you very much guys. Let's dive into the video today. Okay friends, let's have the first question set up on screen. The first question, friends, simply reads that given that x squared plus x minus 2 is a factor of p of x equal to x cubed plus 4x squared plus ax plus b, we should find the values of a and b. We should hence factorize completely, and we should show that for the values of x, this expression cannot take values between 4 and 12. Alright, so guys, let's start with the first. Okay, now let's have our quadratic equation set up. But guys, since this x squared plus x minus 2 is a factor of this polynomial, we have to start by factoring out the x squared plus x minus 2, because we need to apply the factor theorem in this case. So if we factorize this guys by looking for two numbers whose product gives us minus 2 and whose sum gives a coefficient of x, which is 1, those numbers are no other numbers than positive 2 and negative 1. So guys, I made a video on how to factor equations like this. I'll leave a link to that in the description for your convenience. Make sure you check that. Alright, so guys, factoring it is going to give us this. Then now guys, according to the factor theorem, if this our polynomial is a factor of this, it ever means that p of p of each of the roots we get when we equate this our two factors to 0 has to give us 0. That therefore implies, friends, according to the remainders theorem, according to the factor theorem, sorry, it is simply saying that if x plus 2 is a factor, therefore means that what, guys? Therefore means that p of negative 2 has to be equal to 0. This is p of x, right? We are going to put everywhere we see x with negative 2 and we simplify. If we do that, we are therefore going to have negative 2 cubed plus 4 into negative 2 squared plus a into negative 2 plus b equal to 0. Simplifying a bit, we have minus 8 plus 16 minus 2a plus b equal to 0. Simplifying everything, we have 2a minus b equal to 8. Let's call this equation 1. Similarly, guys, if x minus 1 is a factor of the polynomial, it therefore means that p of 1 has to be equal to 0 when we solve x minus 1 equals 0. We have x to 1, means p of 1 has to be equal to 0. That therefore implies we put everywhere we see x with 1, we're going to have 1 cubed plus 4 into 1 squared plus a into 1 plus b equal to 0. Simplifying that a bit, we have 1 plus 4 plus a plus b equal to 0. Simplifying that, we have a plus b equals negative 5. Let's call this equation 2. Now guys, all what is left for us now is to solve for the values of a and b. Now guys, if you take equation 1 plus equation 2, that therefore implies we are going to have negative b and b, they can go. We have 2a plus a, which is 3a. 8 minus 5 gives us 3. So if we divide all 2 by 3, we are going to have a to be equal to 1. Now guys, if we substitute our a equal to 1 now into equation 2, it ever means that equation 2 is a plus b equals negative 5. We put our a equals 1, we're going to have 1 plus b equals minus 5. Bringing 1 to the right hand side, we have b to the same, like negative 6. Alright, so guys, that's our value of, those are the values of a and b. Means our polynomial now can be written as, when we put the values of a and b, we have p of x being equal to x cubed plus 4x squared. Our a is 1, so we have plus x, b is minus 6, so we have minus 6. Alright, so guys, that's it. Then we want us now to factorize the polynomial completely. Okay, now guys, there are a number of ways in which you can do it. The best way in which I would recommend you guys to do it is not by doing long division. If you have been given just one of the factors, then you can use long division, but since two have been given, to factor it means we have to look for one of the factors again. And friends, for us to be able to proceed in that, guys, therefore means that our p of x has to be identically equal to the factor, which is x squared plus x minus 2 multiplied by x plus c, where c is a linear term. Friends, under normal circumstance, the next factor has to have the form ax plus b. But since x times x has already given us x cubed, means the coefficient of x in this case has to be 1. Then we just need a constant term which can call that c. If you open up the bracket, friends, we're going to have p of x equal to x cubed plus x squared minus 2x plus cx squared plus cx minus 2c. But friends, what is our p of x? It is what we have here, right? It is x cubed plus 4x squared plus x minus 6. So if we put that and we take identities, we are going to have x cubed plus 4x squared plus x minus 6 identically equal to x cubed plus x squared minus 2x plus cx squared plus cx minus 2c. Now guys, if we factorize all the terms that have x squared on x squared and the terms that have x as well, we are going to have this using identities. Now if 1 plus c into x squared plus c minus 2x minus 2c plus x cubed is equal to this. At this point now, guys, we are going to use identities by simply equating corresponding entries, by simply equating the coefficients. So the coefficient of x squared in the first case is 4, and the coefficient of x squared in the second case is 1 plus c. That therefore implies our 4 has to be something like 1 plus c. If you solve for c, we have c to be 3. Friends, notice that if you say that your x in this case has to be equal to x, means you're going to have c minus 2 equal to 1, right? C still becomes 3. In the same way, minus 2c equals negative 6, c still becomes 3. All right. So guys, that's it. It therefore means that our polynomial now can be written as x squared plus x minus 2. We factored it out here to be what? X plus 2 into x minus 1, right? That's it. Then our c in this case is to have x plus 3. Great. So guys, that's it. We factored it out already. All right. Then now the Roman 2 say now we should show that for every values of x, this guy cannot take values between 4 and 12. All right. So friends, we will start by letting y to be equal to the function. Cross multiplying, guys, gives us xy minus 3y equal to x squared plus 2x minus 11. If we bring forth all the terms that contain, if we arrange in the form that can look like a quadratic equation, wherefore in this case y is acting as a constant term and x in this case is the main variable, we are going to have x squared plus 2 minus y into x plus 3y minus 11 equal to 0. All right. So guys, for real values of x, we know that the discriminant of this our equation has to be what? Greater than or equal to 0, right? The discriminant, that is b squared minus 4ac, has to be greater than or equal to 0. Keep in mind that whenever b squared minus 4ac is greater than 0, the roots are real and distinct. Whenever it is equal to 0, the roots as well are real. So combining the two results means b squared minus 4ac has to be greater than or equal to 0. Keep in mind that our b in this case is 2 minus y, our a is 1, our c is 3y minus 11. Putting all the values, guys, we're going to have 2 minus y squared minus 4 into 3y minus 11 greater than or equal to 0. Simplifying that, opening all the brackets, we have 4 minus 4y plus y squared minus 12y plus 44 greater than or equal to 0. Simplifying that, we have y squared minus 16y plus 48 greater than or equal to 0. Factoring it out, guys, we are going to have y minus 4 into y minus 12. Looking for two numbers whose product gives 48, whose sum gives minus 16. All those factors must be negative, so we have it like this. Then first, at this point now, we need a number line. The critical solution, guys, keep in mind that the critical solution is the solution that we get by putting each of these factors to 0. Doing that, we are going to have y to be 4 and we have y to be 12. Since this our sign is not a strict symbol, rather it is a partial symbol, it therefore means that what we need to have here are open circles. The function of this open circle is to tell us that the boundaries are included. So guys, if we take any number between from negative infinity to 4, let's take 0. If we take 0, friends, and we put here, we have 0, 0, negative, negative gives positive. So in this region here, we're going to have positive. Then if here is positive, guys, in between here must be negative, and this way must be positive. But we are more interested in the region that has given us greater than 0, namely the positive region. So it has to be. So the range of values now, with the required range of values, friends, has to be, we have y has to be less than or equal to 4, or we have y has to be greater than 4. In essence, guys, since the region from 4 to 12 has given us negative, right? So it therefore means that we don't want that region. It therefore means that, but what is our y, guys? Our y is simply the function. So it therefore means that our function x squared plus 2x minus 11 over x minus 3 cannot take values between 4 and 12. Great. So guys, that's the conclusion. Friends, don't forget to subscribe to the channel. If there's a question you want me to answer for you, leave it in the comment section down below. I'll get back to you as soon as possible. We have our WhatsApp group, guys. Check the link to the WhatsApp group in the description of this video or in the video comment section. Join our WhatsApp group to prepare for your exams well. Proper preparation, guys, prevents poor performance. All right, let's go to question 2, guys. Let's go. Okay, friends, the question 2, guys, as you can see on screen, simply reads that the roots of the equation of x squared minus 2x plus 2 equals 0 has alpha and beta. Find a quadratic equation whose roots are alpha plus 2 over beta and beta plus 2 over alpha. So the next question follows. All right, so guys, let's start with the first part. In cases like this, right, all you need to do is to find your alpha plus beta, that is the sum of roots, then alpha times beta, that is the product of roots, because all of what is going to follow now is going to make use of the two results in which you're going to find. Okay, now guys, let's start. This is a quadratic equation displayed. That's it. Let's find our alpha plus beta, that's the sum of roots, which is giving us negative b over a. Our b is negative 3 over a is 1, so we're going to have negative into negative 3 over 1, so it gives us just 3. Okay, now guys, alpha beta, which is a product of roots, which is giving us c over a. Our c is 2 over a is 1, so we are just going to have 2. Now guys, now that we have this, now we can therefore go ahead now to look for our new sum of roots. The new sum of roots, guys, is simply gotten by replacing the and here we have with positive. So if we do that, we are going to have our new sum of roots, that's n SOR, being equal to alpha plus 2 over beta plus beta plus 2 over alpha. Combining the terms, guys, and simplifying 2 over beta plus 2 over alpha, we are going to have alpha plus beta plus 2 into alpha plus beta over alpha beta. What is alpha plus beta, guys? It is 3. What is alpha beta? It is 2. So simply putting all the values, guys, we are therefore going to have 3 plus 2 into 3 over 2. Simplifying that, we have 6. Okay, now guys, what then is our new product of roots? It is simply gotten by replacing the and symbol, now the and here, with multiplication. So we are going to have 2, we are going to have alpha over 2, alpha plus 2 over beta into beta plus 2 over alpha, guys. Expanding this term, we are going to have alpha plus 2 plus 2 plus 4 over alpha beta. What is alpha beta, friends? It is 2. So putting all the values, guys, we are going to have this. Simplifying, we have 8. Now guys, our quadratic equation normally has to have the form x squared minus the sum of root x plus product of roots equal to 0. What is our new sum of root, guys? It is 6. What is new product of roots? It is 8. So putting everything, guys, we are going to have x squared minus 6x plus 8 equal to 0. Great, that's it. Now the Roman 2 is saying that we should find the value of k for which the roots of the equation x squared plus kx minus 2x plus 2k plus 1 equal to 0 are equal. Okay, now guys, if you look at this equation, right, it does not have the general form of the quadratic equation that we all know. All we have to do is to make it resemble that form. What is making it not resemble is the linear term, that is the coefficient of x, because we have x and we have x, so we have to factor out that x. If you factor out the x, guys, we're going to have the equation turning out to be x squared plus k minus 2x plus 2k plus 1 equal to 0. Now guys, for equal roots, we know that they discriminate, namely b squared minus 4 has to be equal to 0, right? Our b is k minus 2, our a is 1, our c is 2k plus 1. Simply putting everything, guys, we are going to have k minus 2 squared minus 4 into 2k plus 1 equal to 0. Simplifying that, we have k squared minus 4k plus 4 minus 8k minus 4 equal to 0. Simplifying everything, guys, we have k squared minus 12k equal to 0. If we factor out our k, we are going to have k into k minus 12 equal to 0. That therefore means that if the product of two things can give us 0, means at least one of those factors has to be equal to 0, means we're going to have k to be 0 or k has to be equal to 12. Wait, so guys, these are the values of k that we need. Okay, these are the values of k. Okay, now the Roman 3 is saying that a committee of 5 people is to be selected from 4 men and 7 women. In how many ways can this be done if the committee must contain more men than women, with at least a woman included? Okay, so guys, now the key to this problem is that we want to form a committee of 5 persons, right? And we have 4 men and 7 women as candidates. So our goal now is to select it in such a way that we have more men than women, but there must be at least one woman. At least one woman means what, guys? Means from one and above, right? But we must appreciate the fact that the number of men must be more than the number of women. Okay. So now, guys, there are a number of ways which we can do this. In fact, the best way in which we can do it is that we can start by selecting the woman. They said at least one woman means we start from one. So we are going to select one woman now from seven women, and we select four men from four men. Okay, because we they say at least one woman means we have to start from one and start going above, knowing that the number of men must be more than the number of women. So we are going to select one woman from seven, and we select four men from four men. Or, guys, or we can still select two women from seven women, and we select three men from four men. You notice that what, guys? These are the only cases which we are going to have, because if we want to proceed further, means we are going to be saying we are going to be selecting three women from seven women, then two men from eight, two men from four men. You see that the number of women are already more than men, right? So that condition fails. So these are the only possible outcomes which we are going to have. So if we simplify that, guys, we are going to have 7 factorial over 1 factorial 6 factorial. Keep in mind that 4 combination 4 is 1, or means addition. So we have 7 factorial over 2 factorial 5 factorial, multiplying 4 factorial over 3 factorial 1 factorial. Simplifying that, guys, we are going to have an answer of 28 ways. Okay, that's it. So, guys, don't forget to like the video, friends. Give the thumbs up, share it out with your friends. Homework Academy, guys, is going to be very happy if you can do this. Okay, and don't forget to join our WhatsApp for preparation, because it prevents poor performance. All right, let's go to question 3, guys. Let's go. The question 3, guys, as you can see on screen, it simply reads that the function f such that r goes to r, and we need to exclude -2, is defined by f of x being equal to that. So now they want us to show that f is not surjective, and show that if x is so small that x cubed and higher powers can be neglected, then this our binomial expansion can die down to this, and we should find 3 days map is the approximate value of the square root of 99 over 102. All right, so that's what we have. So, guys, let's simply recall the condition for surjectivity. For surjectivity, friends, we simply have to recall subjectivity. The range has to be equal to the codomain of the function, right? And, friends, how do you get the range of the function? The range of a function, guys, is simply defined as a domain of its inverse. So we have to start by finding the inverse of this function. By so doing, we are going to let y to be equal to the function. Solving for x, multiplying both sides by x plus 2, we have xy plus 2y equal to 3x minus 5. Factoring out x by bringing 3x minus 3x to the left hand side, we are going to have x into y minus 3 equals minus 5 minus 2y. Dividing all through by 3 minus y, we have x to the same like 5 plus 2y over 3 minus y. Keep in mind that the function is defined in terms of x, so we have to convert all the x's back to all the y's back to x. So we are going to have f inverse of x being equal to 5 plus 2x over 3 minus x. The domain of this function, guys, has to be the set of all real numbers excluding 3, because the denominator should not be 0, and 3 for x makes it to be 0. Okay, now that we have the range, right, which is the domain of its inverse, we can see that what, guys, that this is not the same like what we have, right? It's not the same like what it presents here. Or better still, guys, since this is the range, the codomain of this function is what, r, right? So you could say that since the codomain, which is all real numbers, is not the same as the range, which is all real numbers excluding 3, it never means that the function f is not surjective. Okay, then now the Roman to now should show that if x is so small that x cubed can be neglected, then this condition is true. Okay, let's start, guys, with our binomial expansion. Let's simply recall that if we have binomial expansion of the form 1 plus minus x raised to the power n, this can die down to 1 plus nx plus n into n minus 1 over 2 factorial x cubed. That is approximately, that's why we are using the approximation sign. If we have to use an equal to sign here, means we have to end up with some 3 dots, which is to show that this is an infinite, there are infinitely many terms as long as n gets very large. Okay, Now guys, we notice that this expression is not in this form, right? We have to force it to be in this form by using our index properties that we know. So the square root of something is the same like that thing raised to the power 1/2, right? And we can bring this denominator down to go up, but the power becomes negative. So we're going to have that. Well, taking the square root of each of the products, we have 1 minus x raised to the power 1/2 into 1 plus 2x raised to the power negative 1/2. Doing the binomial expansion for each of the terms, we start with 1 minus x raised to the power 1/2. We are going to have it being approximately equal to 1 plus 1/2 into negative x. Keep in mind our x in this case is negative x. Our n is 1/2. So we have this. Simplifying it, friends, gives us 1 minus 1/2 x minus 1 over 8x squared. Okay. If we do the same now for 1 plus 2x raised to the power negative 1/2, we are going to have it approximately equal to our n in this case is negative 1/2, our x is 2x. So we have this. Simplifying this, guys, we have an answer of 1 minus x plus 3 over 2x squared. It therefore means that what, guys, that this our original expression, which is simply gotten by multiplying these our two results, we have this, multiplying out both sides. Keep in mind that we don't have to include terms from x cubed and above, so we have to neglect those terms. In the course of multiplying, we neglect those terms since they are very negligible. So we are going to have, if you multiply, we are going to have 1 minus x plus 3 over 2x squared minus 1/2 x plus 1/2 x squared minus 1 over 8x squared. Keep in mind that these are not all the terms, but we have simply selected all those terms that are just from x squared and below. X cubed and above, we have neglected them. So if we simplify these, guys, we simply see our proof coming out to be 1 minus 3 over 2x plus 15 over 8x squared. Okay. Now they want us now to find the 3 decimal places the approximate value for the square root of 99 over 102. So friends, to do this, all we have to do is to equate this now, friends, onto this. Okay, we have to take the square root of 99 over 102 and equate to this our expansion and solve value of x, which will give us this. If you solve the value of x, guys, we're going to have our x to be the same as 1 over 100. That is when we equate square root of 1 minus x over 1 plus 2x to square root of 99 over 102 and solve for x, we have x with that. Then now, guys, we are going to substitute our x equal to 101 over 100 onto this our expansion, 1 minus 3 over 2x plus 15 over 8x squared. If everything, we are going to have the square root of 99 over 102 being approximately equal to 1 minus 2 over 3x, which is 1 over 100. We put in everything, we simplify, guys, we are going to have an answer of 0.985 to 3 decimal places as equation suggested. In fact, guys, the square root of this to 3 decimal places is just approximately the same like 0.985. Okay, guys, that's it. Let's go to question 4, guys. Let's go. Okay, guys, as you can see on screen, the question 4 reads that we should show that cos 2 theta is like 1 minus tan square theta over 1 plus tan square theta, given that 2 cos into 3x minus pi over 3 can be expressed in the form a equals 3x plus b sine 3x, where a and b are possibly constant. Find the values of a and b, and hence the greatest solution of the equation that. Okay, now, guys, let's start with cos 2x cos 2 theta. We know that what, guys, cos 2 theta can be written in the form, can be written as cos 2 theta minus that's cos 2 theta equal to cos square theta minus sin square theta, right? This is according to trigonometry. We can see that this is being divided by 1, right? So we have this over 1. But friends, what is 1? All of us know that sin square theta plus cos square theta gives us 1, right? But let's say it backward. Let's see 1 as cos square theta plus sin square theta. So we are going to have cos theta being equal to cos square theta minus sin square theta over cos square theta plus sin squared theta, since this result gives us 1. If we divide all three in this case, find by cos square theta, we see that we are going to have everything dividing cos square theta. If we now separate each of them, friends, we are going to have cos square theta over cos square theta, which gives us 1. Then we have sin square theta over cos square theta, which gives us tan square theta. We do the same at the bottom. You see that we have the result coming out. We have 1 minus tan square theta over 1 plus tan squared theta. Okay, that's it. Then we want us to express this in the form that, all right. So now, guys, let's simply start with this our expression. So if we simplify the left hand side, guys, we're going to have 2 cos 3x cos pi over 3 plus 2 sine 3x sine pi over 3, which is identically equal to a cos 3x plus b sine 3x. What do we notice, friends? Cos 3x corresponds to what? Cos 3x, right? It therefore means that 2 cos pi over 3 has to be equal to what, guys? 2. 2 cos pi over 3 has to be equal to what? A, which is the coefficient of cos 3x. What is cos pi over 3, guys? That's what is cos 60. Wait, what is cos 60, guys? This 1 half. So we have 2 into 1 half, which gives us our A to be the same like 1. Similarly, guys, if sine 3x is equal to sine 3x, right? It never means that what? 2 sine pi over 3 has to be equal to b. So doing that, we have 2 sine pi over 3 equal to b. Sine pi over 3, guys, is root 3 by 2. So we have 2 into root 3 by 2. Means we are going to have our b to be same like root 3. Okay. Now, those are the values of a and b. The next part now wants us to find the value. We should hence find the general solution of the equation. This. Okay. Now, guys, that's the equation that we have. Let's start by factoring out root 2 from the equation. We're going to have root 2 into a cosine of 3x plus b sine 3x, which is equal to 2, right? But friends, what is a cos 3x plus b sine 3x? That is equal to what? Equal to 2 cosine of 3x minus pi over 3, right? Do you see that this 2 can cancel with this 2 here? And if we divide all by root 3, guys, we are therefore going to have just cos 3x minus pi over 3 being equal to 1 by root 3, right? If we take the cos on both sides, we have 3x minus pi over 3 equal to cos of 1 over root 2. What is cos of 1 over root 2, guys? It is simply pi over 4, right? Or 45 degrees. That is pi over 4. So we are going to have 3x minus pi over 3 equal to pi over 4. Friends, this is a principal value. And for the cosine function, we know that the general solution for a cosine function, guys, is simply given as theta being equal to 2n pi plus or minus the PV. That's the principal value. Our theta in this case is 3x minus pi over 3. PV is pi over 4. So we are going to have 3x minus pi over 3 equal to 2n pi plus or minus pi over 4. At this point, guys, if we divide all by 3, we are going to have our general solution being equal to, or if we carry minus pi over 3 to the right hand side, it becomes positive. If we now divide all by 3, guys, we're going to have the general solution being equal to x to be the same like 2 over 3 n pi plus or minus pi over 12 plus pi over 9. Guys, it is in your own opinion, or it is your option if you choose to separate, okay? But if you choose not to separate, guys, simply leave it like this. Yeah, that's it. Where in this case our n is an integer, okay? N is an integer. I can take both negative and positive whole numbers. Okay, that's it, guys. That's it. Let's go to question 5, guys. Let's go. Okay, friends, let's have question 5 displayed on screen. Question 5, guys, as you can see, simply is that the table shows corresponding values of x and y which approximately satisfy a relation of the form y equal to natural log of ax plus b. Alright, that's it, guys. They want us saying that by drawing a stable linear graph, determine the corresponding values of a and b. Okay, now, guys, that's the table of values. We have x, that. Okay, now, guys, the first thing that we want to do in this case is to linearize this our equation to look like the general form of an equation of a straight line. By so doing, guys, that's the equation in which we have. To linearize this equation, guys, since the natural log function is involved, we may need to take e on both sides. If we take e on both sides, we're going to have e raised to the power y to be same like ax plus b. Keep in mind that e raised to the power anything is just that thing, so we have ax plus b. Now, guys, this equation is already of that form, right? It has respected the equation y equal to mx plus c, where in this case our y is e raised to the power y, our m in this case is a, our x remains x, and our c becomes what? B. So, guys, we need to make a table of values for e raised to the power y. So we'll simply take this is the table of value, guys. So we can therefore say that a graph of e raised to the power y against x is a straight line whose slope or gradient is a and whose intercept on the e raised to the power y axis is b. So we have to make a table of values of e raised to the power y. We have x already, so we have to make a table of values of e raised to the power y. If we take all the y value, guys, and raise them to the power e, we are going to have e raised to the power y equal to that. We're now going to take e now and raise all of them to this their power. This is the table of values that we have. We take y, we are going to have e. We take the first one, we have 1.4. So e raised to power 1.4, guys, give us an answer of 4.1. E raised to power 1.6 give us an answer of 5.0. Doing the same, guys, we have 6.0, we have 6.7, 8.2, and 9.0. Now, guys, are you ready for some magic, guys? Are you ready to see some magic? Let's have our graph displayed. Okay, guys, this is our graph. This is our graph paper. That's it, guys. So we are going to label each of our axes. Keep in mind that we have to create a scale, and guys, I have created a suitable scale that is going to work perfectly. So we are going to take 2 centimeters here to represent 1 unit, and we are going to label our vertical axis as such. We have we start with 4.1, we have 5.5, 6.9, 8.3, that. So, guys, the question I'll leave for you guys to answer in the comment section is to tell me the scale of this my graph of the vertical axis. Tell me the scale, like 2 centimeter here represent how many units, guys? Just write it in the comment section down below. Okay, let's start plotting, guys. The axes have been labeled e raised to power y, x. So the first one, we have x equal to 1, e raised to power y to be 4.1. So we are going to have it being at this point. So we have it here, we have it like that. If we plot the next, we have 2 and 5.0, we have it here. The next 3 and 6.0, we have it there. 4 and 6.7, we have it that. 5 and 8.2, we have it that. And the last 6 and 9.0, there we have it. Then now we are going to connect this our point now with a smooth straight line. So, guys, you notice that this is the best straight line, right? It's the best. Why? Because it averages the point. This point is outside, right? And this point also is outside. All the points are on the line. So, guys, this is the best straight line. So at this point now, all we have to know is to get the slope of this our graph. Guessing the slope means we have to come out with a tangent triangle, with a triangle that is going to indicate the points we have to take. So we are going to take the first point, that is the point. At this point, we are going to have 2.5 and 5.5. Then at this point, guys, we are going to take 5.5 and 8.44. If you get it very right, this is going to be 8.44. Then now, guys, the gradient or the slope has to be given as a change in e raised to power y over a change in x. Change in e raised to power y means we are going to take the second value minus the first over. For the x, we have the second as well. That is 5.5 minus 2.5. Simplifying that, guys, we have an answer of 0.98. But, guys, what did we say? That our gradient is a, right? So it means our a is equal to 0.98. But the question said to the nearest whole number, right? To 1 decimal place. So to 1 decimal place, guys, we are simply going to have 1.0 to 1 decimal place. Okay, that's it. Then now, guys, to get the value of b, you notice that b is simply the intercept on the e raised to power y axis, and it is gotten at a point when the curve touches the y axis. At that point, for which the graph in the horizontal, for which the values in the horizontal axis, guys, must start from 0. If your value set did not start from 0, guys, therefore means you need to calculate this value and not by reading from the graph. So if you read it so well, guys, to your scale, you see that the value of b, that's the intercept, is going to be 3.1. That's it, guys. That's it. Alright, guys, if there's any question, leave in the comment section down below. I'll get back to you as soon as possible. Let's go to question 6. Okay, if you look at question 6, it simply reads that the complex number z is such that z is equal to 3 over 1 plus I minus 1 plus I. Then the a part is now should express z in the form x plus yi, where x and y are real numbers. Then we should find the argument of z, hence deduce the argument of z raised to the power 6. The c part is now should find the range of values of x for which the absolute value of 5 minus x over 2 plus x is equal to x minus 5 over 2 plus x. Alright, so, guys, let's start with the complex number of that. So all we have to now, since this our other part, guys, is already of this form, right? So we have to work with this other part, that is a fraction. We multiply top and bottom by the conjugate of bottom, which is 1 minus I. So we're going to have 3 into 1 minus I over 1 plus I into 1 minus I minus 1 plus I. Simplifying the bottom and the top, we have 3 minus 3I over 2 minus 1 plus I. If we reduce this guy, we are going to have 3 over 2 minus 3 over 2I minus 1 plus I. Simplifying by adding the I terms and the I terms, the real terms to real terms, we are going to have 1 half minus 1 half I. So z is of this form, and our x in this case is equal to 1 half, y is minus 1 half. All right, that's it. That's it. Then now, guys, to get the next part wants us to find the argument of z, and hence use the argument of 0 is equal to 6. But friends, let's simply recall that the argument of 0 is equal to 6 is the same like 6 times the argument of z. Now, guys, let's get the argument of z. Let's simply recall that if we have an argon diagram of this form, where this is the imaginary axis, the negative one specifically, then this is the positive real axis. Now, 1 half is real, right? So this is where it's going to be found on the positive real axis. Minus 1 half is negative, so it's going to fall on the negative imaginary axis. Means the angle has to be between the positive real axis and the negative imaginary axis. So it is going to be that angle with respect to the positive real axis. So this is going to be the angle theta. That therefore implies, guys, our argument of z now has to be given as minus tan inverse of the imaginary over the real. Why minus? Because it's found on the fourth quadrant. If the angle is found in the first quadrant, it is simply going to be tan inverse of imaginary over real. If it's found in the second quadrant, it's going to be 180 minus this result. It's found on the on the third quadrant. It is going to be negative of 180 minus this result. Now on the fourth quadrant, it has to be negative of tan inverse of imaginary over real. So guys, our imaginary in this case is 1 half. Keep in mind that the sign negative simply tells us the position where it is found on the diagram diagram. We don't need to put the negative sign inside again when getting it. So we're going to have 1 half of 1 half, which gives us 1. So we're going to have tan inverse of 1, which is going to give us minus tan inverse of 1, which gives us minus 45 degrees. Wait. So guys, that's the argument of z that we have. But friends, to get the argument of z raised to the power 6, we are going to have 6 times that result. We are going to have 6 into minus 45 degrees, which is going to give us an answer of minus 270 degrees. But friends, we want this argument to be between minus 180 and 180. So we are going to add multiples of 2 pi to the result. So if we do that, we are going to have 2 pi is 360. So we have minus 270 plus 360, which gives us an answer of 90 degrees or pi over 2. So guys, that is it. That's the angle it makes. All right. So guys, that's it. That's it. There's something you don't understand, feel free to ask me in the comment section down below, guys. I'll get back to you as soon as possible. The next part wants us to find the range of values for which this our equation is true. Okay, so guys, that's the inequality in which we have. Let's simply solve this, guys, by simply using the definition of the absolute value function. Let's know that the absolute value of x, guys, is simply defined as x provided x is greater than or equal to 0, and negative x provided x is less than 0. Now, guys, let's consider this in terms of cases. Let's look at case 1, where the absolute value of x, guys, is just the same as x. It therefore means that this our 5 minus x over 2 plus x now simply becomes just the same part, right? If you cross multiply, guys, we are going to have our 5 minus x to be the same like x minus 5. Simplifying that gives us our x to be the same like 5. Okay, now guys, x equal to 5 is okay, right? Let's look at case 2, when our absolute value of x, guys, is equal to negative x. In that case, 5 minus x over 2 plus x simply becomes x negative of x minus 5 over 2 plus x. Simplifying that result, guys, is going to give us an answer of 5 minus x equal to x minus x plus 5. Simplifying that gives us our 5 to be the same like 5. Or, guys, 0 equal to 0 means this condition is true no matter the value of x you put. So we have taken care of the fact that this can be equal to just x and this can be equal to negative x. Now, guys, let's take care of the domain of the two functions. Let's take care of the domain. We don't want our x to be the same as we don't want the bottom to be 0, right? It never means that, what, guys? It never means that in this case. Now, if we look at the domain, we have to take care of the domain, guys. It's very, very important. It means that our x plus 2 should not be equal to 0. Means our x should not be equal to negative 2. Means the range has to be equal to x such that, guys, such that x is less than negative 2 or x greater than negative 2. Then guys, or we can simply write this as from negative infinity we end at negative 2, continue from negative 2 now to positive infinity. Since 5 equal to 5 means you can take all values of x. Alright, so guys, this is the required range we're asked to get. Alright, that's it. So guys, let's go to the next question. Okay guys, question 7, which that we should get the integral from 0 to 1 of x e raised to power x plus 2 dx. Find the area bounded by the curve h of x and x-axis when x equals to 0 and x equals to 1, where h of x equals to x minus 2 over 2x plus 1 and that should show that. Alright, let's start guys, let's not waste time. So guys, we notice that this integral is a very nice form for integration by part, right? So that's what we have. So we are going to let our u to be equal to x and our dv to be something like e raised to power x plus 2. Differentiating u gives us just the x. Integrating dv guys with respect to p gives us e to be same like e raised to power x plus 2. According to integration by part method, it's saying that we shall have, if we have the integral of u dv, this can die down to just u times b minus the integral of p du. Our u we know, our v we know, du and dv we also know. So if we plug in everything guys, we're going to have the integral from 0 to 1 of x e raised to x plus 2, the x being equal to u is x, b is e raised to power plus, we're going to have that minus the integral from 0 to 1 of v du. So we're going to have e raised to power x plus 2 dx. But friends, what's the integral of this guy? It is simply the same e raised to power x plus 2, right? So if you do that, we are going to have this to be same like x e raised to power x plus 2 minus e raised to power x plus 2. Limits of the equation guys are from 0 ending at 1. Plugging in the upper limit guys, we are going to have 0. If we plug in the upper limit guys, we are going to have 0 because 1 for x means we are going to have e squared minus e squared, which is simply that's e raised to power p minus e raised to power p, which is simply 0. Then minus the lower limit, which is going to be plugging in 0. This first term is out. X here is 0, so we're going to have negative e squared. Negative negative gives us positive, so we're going to have an answer of just equal to e squared. Okay. The next part now wants us to find the area enclosed by the curve h of x, the x-axis, where h of x equals to that. Alright. So guys, the area, according to the Riemann's approximation for an area, it is simply given as the definite integral going from 0 to 1, that's the x values of just h of x dx. That therefore means we're going to have the integral from 0 to 1 of the h of x, which is given as this. But friends, we have to express in partial fraction to be able to integrate so well. So if we express in partial fraction, guys, the denominators are all linear factors and the degree of x at the top is less than at the bottom. So we are just going to have a over the first plus b over the second. If we multiply top on top the whole entire expression by the LCM, we are going to have a into x plus 1 plus b into 2x plus 1 equal to identically equal to x minus 2. If we substitute our x to be the same as negative 1 means we're going to have negative b to be same like minus 3, simplifying that we have b to be same like 3. So guys, I have a video where I showed you guys how to get the values of a and b with seconds, within seconds, okay, in 10 seconds even, you just get them. So check out the link in the description and the video comment section, you find that link. Okay, so guys, similarly, if you put our x be same like minus 1 half, we are going to have minus 1, we are going to have 1 half a to be same like minus 5 over 2, simplifying that we have our a to be same like negative 5. That therefore means that we are going to put everything, we are going to now be seeing the integral going from 0 to 1 now of this, which is equal to that minus 5 over 2x plus 1 plus 3 over x plus 1 dx. So guys, according to how we can integrate linear functions, we are going to have minus 5 over 2, because we are going to have minus 5 over 2, the natural log of 2x plus 1. But since the derivative of 2x plus 1 is 2, we are going to divide by 2. Here, the derivative of x plus 1 is simply 1, so we don't bother, so we are going to have this. Limits of integration, guys, are from 0 ending at 1. Plugging in the upper limit minus lower limit, guys, we are going to have our 8 be same like 5 over 2. That's negative 5 over 2, natural log of 3 plus 3, then 2 minus 0. Simplifying that, guys, completely, we are going to have 1 half the natural log of 64 over 243. Okay, that's the answer. The Roman theory wants us to show that the gradient of the curve defined by x squared plus 2xy plus y squared equal to 4 is a constant function. It's a constant. Okay. Guys, the gradient is simply gotten by differentiating the function with respect to x. But before then, guys, let's look at something. If we try to factor out this our expression, you can die down just to x plus y or that squared y. If you simplify this, you're going to have back this. At this point now, guys, taking the square root, you have x plus y equal to plus or minus 2. At this point now, it means your y becomes plus minus 2 minus x. If you differentiate at this point now, differentiating plus minus 2, that's a constant, you have 0. Minus x, differentiating minus x gives us negative 1, which is a constant, right? So hence the derivative of this gives you a constant. All right, that's it, guys. That's it. Let's go to question 8, guys. Let's go. Okay, the question 8, guys, as you can see, simply reads that with respect to the origin O, the points A and B have position vectors that we should find the Cartesian equation of the plane ABC, the sine of the angle BAC. We should prove by induction that this is that. All right. So guys, let's start. To get the Cartesian equation of the plane ABC, it simply has the form A dot B, that's arrow dot n being equal to A dot n, where arrow in this case, guys, is simply the vector xi plus yj plus zk. N is a normal to that plane. Then friends, our A is any fixed point. The normal to that plane is given as AB cross AC. Now guys, to get the vector AB, we are going to have OB minus OA. These vectors are with respect to the origin, so this automatically is OA, this is OB, and this is OC. Subtracting these two guys gives us our A, which is like 2i plus j plus 3k. That is 3 minus I, which is 2i, 3j minus 2j, which is j, 4k minus k, which gives us 3k. Similarly, guys, our AC is OC minus OA, which we subtract gives us minus 2i minus j minus 2k. Means our n, which is given as the cross product of these two vectors, we arrange them as like these guys. Note the pattern, guys. We simply suppress the first row and the first column. They are going to be seen minus 1, minus 2, minus 3. That the determinant of that, guys, doing that for all of them. Keep in mind that j in this case has with negative, so we are going to have that. Simplifying the expression so well, guys, give us an answer of I minus 2j. Okay. Now, guys, since we have value of n, now to get the Cartesian equation, it has to be multiplying this our guys now with xi plus yj plus zk, give us x minus 2y equal to minus x minus I plus j minus k, dotting it with I minus 2j. If it does so well, guys, you're going to have x minus 2y equal to minus 1 minus 2. Simplifying gives us x minus 2y equal to minus 3. That is a Cartesian equation, guys. In this case, I've used the first point, this third point, to be the fixed point. You can use any of these points, guys, any of them. You're going to have a different value of c, okay, the different value. So that's it. Okay, now, guys, the B part wants us to get the sine of the angle BAC. So guys, generally, if omega is the angle between BAC, that means that sine omega is given as the magnitude of AB cos AC. That's the normal all over the magnitude of AB multiplied by the magnitude of AC. The magnitude of AB, guys, is simply going to be the square root of sum of squares. Doing the same thing for the bottom, we have that AB and AC, guys, have their values here, right? You will simplify now, friends. We're going to have an answer of square root of 5 over 3, square root of 14. So, guys, that's what we have. Now, the next part wants us to prove by induction that this is true. Okay, so guys, let's have the statement. That's the representative of that form, guys. So let's say that whenever our r or our n is equal to 1, guys, means the left hand side simply becomes 2 into 1 minus 1, which gives us 1. Then the right hand side now, friends, simply becomes 1 squared, which is 1. So the statement is true for n equal to 1, since the left hand side equals the right hand side. Okay, now, guys, if we assume that the statement is true for n equal to k, then we add the induction hypothesis. Means we are going to have k squared plus 2 into k plus 1 minus 1. Simplifying these, guys, give us our k squared plus 2k plus 2 minus 1. Simplifying, we have k squared minus 1, all that squared. Since we are able to substitute n in this case with k plus 1, means the statement is true for all values of n equal to k plus 1. So we can conclude that since the statement is true for n equal to 1, n equal to k, and k plus 1, then it is true for all values of n greater than or equal to 1. Wait. So, guys, that's it. Let's go to question 9, friends. Let's go. Okay, guys, our question 9 simply reads that, as you can see on screen, it reads that two circles S1 and S2 are defined by the equation S1 such that we have x squared plus that. S2 also has been defined as that. Okay, then now, guys, they want us now to show that S1 and S2 touch each other internally. Then we should find the equation of the common tangents to the point of at the point of contact. Then Roman 2 should find the inverse of this matrix and hence solve this equation given. Okay, now, guys, let's simply recall the condition for two circles touch each other internally. Let's have a circle of this form. Let's have another circle which touches it internally, that's inside. Now, guys, let's just say that this small circle has a center at this point. Then, friends, now let's say the center of this small circle is C1. Then the big circle has the center of this form, and the center of the big circle we can call it C2. Now, guys, let's simply represent the radius of C1. Let's call the radius of C1 R1, and the radius of C2, let's call it R2. Now, guys, let's represent the distance between the center of the two circles. Let's simply represent this as a distance. Now, guys, what do you think is the condition for these two circles to touch each other internally? Do you see that the two circles will touch each other internally if the distance between the centers of the two circles is equal to what? The radius of the big one minus the small one. Here, guys, just in this diagram, you can see that the distance between the center of C1 and C2 has to be the same like what? The radius of the big circle minus the radius of the small circle. So if we do that, guys, let's have the equations of that form. These are the two circles. Let's try to get the radius of the first one. By so doing, guys, we are going to complete the square of the x values and the y values. So if you complete the square, guys, we are going to have s1 to be same like x minus 2 squared plus y minus 2 minus 3 squared equal to 1. Wait, so, guys, at this point now we can say that the center is going to be at the point 2 comma 3 when you substitute when you equate your x and y brackets to 0. We have 2 and 3, and the radius is going to be the square root of 1, which is simply 1. Now, for the circle S2, which is that, if we complete the square, guys, so well, we are going to have the center to be the same like at the point 2 comma 4. Now, friends, if that's the case, means the radius has to be at the point R, which is 2 squared, which the radius is 2. Now, guys, what then? Now that we have the radius of both of them, now, friends, it therefore means that we can therefore go ahead now to say that since the difference between the radii, between the radius of the two of them, that is R2 minus R1, keep in mind that R2 is 2, R1 is 1, so we're going to have 2 minus 1, which gives us an answer of 1. And let's keep this 1, guys. Let's now find the distance between the centers of the two circles. These are their centers, right? 2, 4 to 2, 3. Distance between 2 points, guys, how do we get it? The square root of the difference between their x and y values squared, we are going to have equal to 1. So since 1 is equal to 1, guys, means you can conclude that S1 and S2 touch each other internally. So, friends, I'm very, very sorry that here is disorganized, okay? Just try to manage it, okay? Here ought to have been, at least you guys know how to place them, right? Good. Okay, that's it. Then, now, friends, to find the equation of their common tangents, we simply have to take S1 minus S2 or S2 minus S1. So if we do that, guys, we are going to have the first circle minus the other one, means we are going to have 2y minus 4 equal to 0, means we are going to have our y to be the same as 2. Okay, so y equal to 2, guys, is simply the tangent to that circle that touches the two circles at one distinct point. Okay, now, guys, now that we have had the first part, let's look at the next part, which is the matrix that has been given m equal to that. They want us now to find the inverse of this matrix, but before then, guys, we have to get a determinant. The determinant of the matrix, guys, is simply gotten as we have 0. We suppress this row and this column. We are going to have this. We have 2, and we have 1 times 2 is 2 minus 2, which is 2. So if we do that, this is what we're going to have, guys. Simplifying, give us the determinant of n to be same like negative 6. Now, guys, we need to get the cofactors of m, which is simply gotten by doing the same thing, but the signs alternate between positive, negative, positive, negative, positive, negative, positive, negative, positive. Suppressing the first element here, the first row and the first column, taking the determinant of the rest that we have, guys, in that same in the same pattern like this. Okay, in the same pattern we are going to have this. Simplifying this, guys, you're going to have 4 0 minus 6 minus 5 minus 3 6 3 3 minus 6. Then now, guys, we have to get the transpose of these cofactors. The transpose of these guys is going to be interchanging the rows as column, putting columns as rows. We are going to have 5 minus 4 minus 5 3 0 minus 3 3 minus 6 6 minus 6. Now, guys, the inverse of m is given as 1 over the determinant multiplied by the adjoint of the matrix. So this is what we're going to have, guys. This is the adjugate. Then now, guys, to solve this our equation means we have to take the inverse, which is this, and multiply by the corresponding results that is our equation is supposed to give us. So it means our x values, x comma y, has to be, if we multiply 1 over negative 1 over 6 instead, we're going to have this, multiplying it now with the result that these equations are supposed to give us 5 13 9. Multiplying it out, guys, we're going to have minus 10 over 3 plus 65 over 6 plus that, all of these, guys. Simplifying it, guys, give us our x in coordinate form to be the same as 3. We have 3 2 1. So equation 10, guys, as you can see, showed out to show that the series as n goes from which the starting value is 1, ending at n of 2 into 1 third into r minus 1 is equal to 3 into 1 minus 3 raised to the power n. Hence, we should sketch this curve. Okay, now, guys, let's get started. Let's this is the sum, right? So, guys, this our series now from n equal to 1 ends at n of this now can be written as, we can simplify this as 6 times the series from 1 to n 1 third raised to the power r, right? Because we have 1 third raised to the power r minus 1. We can divide it. We are going to have 1 third raised to the power negative 1. The negative 1 third can multiply these two to give us 6, so we can put a 6 outside. So if we do that, this is what we are going to have. Now, guys, do we see that this term is simply a geometric progression, and the sum of the first n terms of the geometric progression whose value starts at 1 and ends at n is simply given as Sn to be the same like a into 1 minus r raised to the power n over 1 minus r. That therefore implies, guys, if we do that everything, we're going to have 6 into this, our sigma is what Sn, right, into our a is 1 third, because the starting value is 1, so we're going to have a is 1 third into 1 minus r is 1 third again, and we have n over 1 minus r, which is 1 third. Simplifying the result, guys, gives us our 6 Sn to be something like 1 third minus 1 third into 3 raised to the power negative n over 2 over 3. Multiplying top and bottom by if we multiply top of this equation, or whether if we divide all through by 6, we're going to have Sn to be something like 1 third minus 1 third into 2 raised to the power negative n over 1 over 9. Multiplying top and bottom now by 9, guys, we are going to have 3 minus 3 into 3 raised to the power negative n. Factoring out 3, guys, we have our proof coming out, Sn equal to 3 into 1 minus 2 raised to the power negative n, guys, as required. Okay, as required, guys. That's it. Alright, the next part now wants us to sketch this curve showing all the intercept, asymptotes, and turning points. Alright, so, guys, that's the curve in which we have. Let's let our y to be same like the function made from the curve. Then, guys, in this case now, we have to start by getting the domain of definition. To get a domain, guys, we don't want the bottom to be 0, right? So we are going to have x squared minus 4, which should not be equal to 0. That means our x should not be equal to plus or minus 2. Now, guys, since you have a domain now, we have to get the limits of the function at the boundaries of the domain. We now get the limit as x goes to negative 2 now from below of this our function. If we take a value that is less than negative 2, guys, slightly, we can take negative 2.1. If we put here, guys, we're going to have the sign to be same like positive. So we're going to have positive. So, and keep in mind that this is a limit at the domain. So we are going to have infinity. It is going to be infinity. The sign now tells us if it's positive infinity or negative infinity. In this case, the sign is positive, so we are going to have positive infinity. Similarly, guys, take the limit as x goes to positive 2 now from above. We have the same positive we have the same positive infinity. In fact, friends, in fact, this function is an even function, and as such, we expect it to be symmetrical about the line x equal to 0, that is the y-axis. Wait. Okay, now, since we have the limit at the boundaries of its domain now, guys, we also have to take the limit now. Since we have taken the limit of a finite value and we have an infinite means we can conclude that the line x equal to 2 and x equal to -2 are vertical asymptotes. Wait, then now we have to now get the limit as s goes to plus minus infinity of the function. If we do that, guys, we are going to have an answer of 0, means you can conclude that the line y equal to 0 is a horizontal asymptote. Now let's get the gradient function. That's the turning point. At turning point, guys, we have to differentiate. So if we differentiate this guy by simply applying the product rule, bottom constant differentiate the top, differentiating 1 is 0, so we are going to have 0 minus 2x over x squared minus 4 squared. If we do that, guys, we are going to have this. Then let's record that at the turning point, our dy by dx has to be equal to 0. So if we put this to 0, we are going to have x to be equal to 0. When x is 0, guys, we put in back x equal to 0 into the original function. We're going to have y placing like -1/4. So that's what we have. Then now, guys, now that we have the corresponding values of x and y, so we can see that our x has to be equal to 0 and y is -1/4. These are our turning points. Okay. Now, guys, though the question did not talk about the variation table, let's just give a sketch of it, okay? We won't include everything. Let's just give a sketch of it. Just a sketch so I can see the nature of the function. So the variation table comprises of x, f prime of x, f of x, as well as a limit at the boundaries of its domain. So we are going to have minus infinity here. At this point, we have -2. Here we have 0, 2, and we have positive infinity. So now, guys, if you take any value between -infinity and -2 now, and we put into this our gradient function, we are going to have for this sign being positive. If we do that here, we still have positive, right? But here we have negative, and here we have negative. And where we have a transition between positive and negative means there's going to be a turning point, and at this point x is 0, right? X equals to 0 is our turning point. So we see that the curve in this case is increasing in the interval from -infinity to -2, increasing from -2 to 0, but decreasing from 0 to 2, and still decreasing from 2 to positive infinity. So that's it. So guys, this is just a sketch of the variation table. If you care, you can put in the values where it increases and ends and so on, guys. They will not give you a mark because they did not ask for it. Okay. Now, guys, let's sketch our curve because we have everything now. Let's call this the y-axis. Well, let's have this. We can call it the x-axis. All right. Let's simply insert all the values that we need. We need -2 because -2 and 2 are our asymptotes, vertical asymptotes specifically. So now, in such a case, guys, the first thing you start by indicating are the asymptotes, and the asymptotes are being drawn with broken lines. So we have an asymptote at the point where we have x to be -2, which is with red broken lines. We have it at this point where x is 2, we have it in yellow broken lines. Now, since our asymptote of y equal to 0 is just the x-axis, right, we don't need to indicate it. We can just leave it blank, okay? No need to indicate it. Now, let's simply look at something, guys. Let's look what is the limit as x is coming from -2 from the left. Do you see that y in this case was going to positive infinity? So we are going to have our curve, our first curve being of this form, okay? When x is coming towards -2 from the left, y is going towards positive infinity. This is at the point where this laser is showing, guys. Then, guys, what's the limit as x coming to as x approaches 2 from the right hand side? What is happening to y? Y still goes to positive infinity, right? So we are going to have a curve of this form where x is approaching from the right, y still goes to positive infinity. Now, what happens in the region from -2 to 2, guys? What do you notice? Do you see there's a turning point at the points x equal to 0 and y equal to this, right? So it therefore means that our curve is increasing from -2 to 0 but decreasing from 0 to 2. So we are going to have the curve being of this form. Okay, it's going to be of this form. It's going to respect its asymptotes, increases from -2 to 0 but decreases from 0 now to neg to x equal to 2. Wait, so guys, this is the curve that we asked to sketch. This is it. We can therefore label this as a graph of y equal to 1 over x squared minus 4. So guys, that's it. We've come to the end of the correction of this year. If it's something you don't understand or it's a suggestion that you have, let me know in the comment section down below, guys. I'll get back to you as soon as possible. Have a blessed day.